The day often begins with a subtle negotiation, a stiffness in the knees, a familiar ache in the hips, a crackle from a shoulder that speaks of years lived and miles traveled. For millions, this is the accepted narrative of aging, a story of simple wear and tear, where the body's machinery slowly, inevitably, breaks down. But what if this narrative is fundamentally wrong? What if the chronic pain and stiffness in one's joints are not the result of a passive decline, but an active, internal assault? Science now reveals a startling truth. A forgotten family of enzymes, produced by the body itself, could be the hidden architects of this daily betrayal, actively eating away at the very cushion that allows for a life of movement and freedom. This is the story of how the body can become its own worst enemy, and how a natural enzyme blocker, hidden in plain sight, may hold the key to calling a truce. For decades, the explanation for joint discomfort was disarmingly simple. It was compared to the tread on a tire, wearing thin after countless revolutions. Cartilage, the smooth, rubbery tissue that cushions the ends of bones, was thought to simply erode over time from mechanical stress. This explanation is not entirely false, but it is dangerously incomplete. It fails to answer a crucial question. Why do some individuals maintain smooth, healthy joints well into their 80s and 90s, while others experience significant discomfort by their late 50s? The difference, researchers have discovered, lies not just in the wear, but in the repair and demolition cycle within the joint itself. It is a process governed by a microscopic world of signals and messengers. Within the body exists a sophisticated maintenance crew. These are specialized enzymes known as matrix metalloproteinases, or MMPs. Their designated job is to break down and recycle old, damaged collagen and cartilage tissue to make way for new, healthy tissue. In a balanced system, they are essential for healing and regeneration. They are the demolition team that clears the site for new construction. But in many individuals experiencing chronic joint issues, this system has gone haywire. The demolition crew has stopped listening to the foreman. Imagine these MMP enzymes receiving a constant, unrelenting order to destroy, with no corresponding signal to rebuild. They begin to break down healthy cartilage, not just damaged tissue. They start to dismantle the very structure they were meant to maintain. This process is relentless. It is insidious. It is the body attacking itself. The smooth, gliding surface of the joint becomes rough and pitted. The cushion thins. The result is the grinding, the stiffness, and the deep, persistent ache that can diminish one's quality of life. This is not passive wear. This is an active, enzyme-driven dismantling of one's own mobility. This changes everything. Rehook. But why would the body turn on itself with such destructive force? The answer lies not in the joints themselves, but in a master signal that has gone terribly, silently wrong. The rogue command that unleashes these cartilage-eating enzymes has a name: chronic, low-grade inflammation. This is not the acute, helpful inflammation experienced after an injury, the swelling and redness that signals healing. This is a different beast entirely. It is a persistent, systemic hum of inflammation that can simmer for years or even decades without obvious symptoms. This systemic inflammation acts as a constant on switch for MMP production. It whispers to the cells in the joint lining, day after day, year after year, to produce more of these destructive enzymes. The primary drivers of this silent fire are often the very staples of a modern lifestyle. Highly processed foods, refined sugars, and certain industrial seed oils are well-documented triggers. They are foreign substances that the body's immune system can perceive as a constant, low-level threat, keeping the inflammatory response on high alert. Over time, this sustained state of alarm is what gives the destructive orders to the MMP enzymes in the joints. The body, in its effort to protect itself from a perceived dietary threat, inadvertently wages war on its own cartilage. One may find themselves eating what is considered a relatively healthy diet, yet still experience the effects. The inflammatory threshold is different for every individual, influenced by genetics, stress levels, and a lifetime of environmental exposures. The result, however, is the same. The body's natural maintenance system is turned into a self-destructive weapon. For many years, the conventional approach was to try and manage the pain that resulted from this breakdown. But this is like trying to mop up the floor while the faucet is still gushing. A more sophisticated understanding now points to a different strategy. Not just managing the pain, but stopping the destruction at its source. It means finding a way to turn off the faucet. It means blocking the enzymes. Rehook. So if inflammation is the trigger and enzymes are the weapon, Is the only answer a lifetime of powerful anti-inflammatory drugs? A groundbreaking series of discoveries in the plant kingdom suggests a far more elegant and perhaps more intelligent solution. Nature has been engaged in chemical warfare for millions of years. Plants, being stationary, cannot run from predators or diseases. Instead, they have evolved to produce a vast arsenal of complex chemical compounds to defend themselves. Scientists have discovered that many of these protective compounds, known as polyphenols, can interact with human biology in profoundly beneficial ways. Within this massive family of plant protectors, a specific class has been identified that does something remarkable. They don't just help to quell the fires of inflammation. They go one step further. They physically and directly interfere with the cartilage-eating MMP enzymes. They act as natural enzyme blockers. The mechanism is a beautiful example of biochemical elegance. Think of the destructive MMP enzyme as having a specific keyhole, or an active site, which it uses to lock onto and dismantle cartilage. These natural plant compounds are shaped in such a way that they can fit perfectly into that keyhole. But they are not the right key. They cannot turn the lock. By occupying the keyhole, they simply block it. The enzyme is neutralized. It is rendered harmless, unable to latch onto its target. The demolition machine is effectively disarmed, not by destroying it, but by simply getting in its way. This provides a shield for the cartilage, allowing the body's natural, slow-paced repair processes a chance to catch up. These protective compounds are not found in rare, exotic plants from distant jungles. They are surprisingly common, found in foods that many people consume every day. Green tea, berries, and even dark chocolate are rich sources. This is a fact, but the concentration and specific type of these enzyme blockers vary dramatically from one food to another. Some are moderately effective, others are truly potent. Rehook. But while many foods contain these protectors, one common fruit, often overlooked for its joint protective power, contains a uniquely potent form of this enzyme blocker. Are we throwing away the most powerful part? The pomegranate. For thousands of years, it has been a symbol of health and vitality, revered in ancient cultures for its medicinal properties. Modern science is now beginning to understand why. The pomegranate contains an exceptionally powerful class of polyphenols, most notably one called punicolagen. Punicolagen is a master enzyme blocker. When it is absorbed by the body and travels to the joint tissues, it exhibits an extraordinary ability to seek out and neutralize multiple types of MMP enzymes, including MMP13, which is considered one of the most aggressive destroyers of cartilage collagen. Its power is not a matter of folklore. It is a matter of documented scientific evidence. A landmark study published in the 2014 edition of the Journal of Nutritional Biochemistry investigated this exact mechanism. Researchers exposed human cartilage cells in a lab environment to inflammatory signals that would normally cause a massive spike in the production of these destructive enzymes. But when they introduced a concentrated pomegranate extract rich in punicolagen, the results were stunning. The production of the cartilage-eating enzymes was reduced by nearly 60%. The extract didn't just soothe the inflammation, it directly disarmed the primary weapon of joint destruction. However, there is a crucial catch. The highest concentration of these life-saving punicologens is not found in the sweet, juicy seeds or arils that people typically eat. It is found in the tough, bitter husk and the white, membranous pith, the very parts of the fruit that 99% of people throw away. One would have to consume an impossible amount of pomegranate husks to achieve the therapeutic levels of punicologen used in these successful studies. The compounds are there, but for all practical purposes, they are locked away, inaccessible to most. The solution was hidden in plain sight, yet just out of reach. Rehook. Consuming pounds of bitter pomegranate peel is impractical. But what if modern science has found a way to unlock and concentrate this protective power, creating a true shield for the joints? The story of how this was developed is almost as remarkable as the science itself. The challenge was clear: how to extract the potent punicologens from the discarded parts of the pomegranate and concentrate them into a form that the human body could easily absorb and utilize. This is a field of study known as bioavailability. A protective compound is useless if it cannot survive the digestive process and reach the target tissues, like the cartilage in the knee or hip. Researchers explored numerous methods. Simple grinding and drying of the peel proved inefficient. Chemical extraction using harsh solvents raised safety concerns. The breakthrough came from a sophisticated, multi-step water-based extraction process. a technique that uses different temperatures and pressures to gently coax the valuable compounds from the plant material without damaging their delicate chemical structure. This process isolates and purifies the punicalagins, creating a standardized extract that guarantees a specific, potent dose in every serving, a dose that would be impossible to obtain from diet alone. It takes the power of hundreds of pomegranates and concentrates it into a small, easily consumed form. This process was a painstaking endeavor that took years of refinement. With a safe and potent extract finally developed, the next step was to test it in the real world, on real people experiencing the daily realities of joint discomfort. A rigorous, double-blind, placebo-controlled study was designed. This is the gold standard of clinical research. Participants were divided into two groups. Neither the participants nor the researchers knew who was receiving the concentrated pomegranate extract and who was receiving an identical-looking placebo. They tracked dozens of biomarkers, but the most important data came from highly sensitive imaging technology that could measure the thickness and health of cartilage in the knee joint with microscopic precision. The researchers gathered, watching the screens that monitored the cartilage density of the study participants. For weeks, the control group taking the placebo showed the expected, steady decline, the accepted narrative of wear and tear playing out in real time. But for the group receiving the concentrated enzyme blocker, the data began to show something that seemed impossible, something that defied the conventional understanding of joint aging. The line on the graph, which should have gone down, started to level out, and then, in a handful of subjects, it began to do something else entirely. It started to go up. Let me repeat that. The measured density of their joint cartilage, the very tissue that medical textbooks tell us cannot be regenerated, began to increase. Was it a mistake? A glitch in the multi-million-dollar imaging equipment? A statistical anomaly? They ran the diagnostics. They recalibrated the machines. They double-checked the data and ran the scans again. The result was the same. The line kept creeping upwards. This wasn't just halting the damage. This was evidence of reversal. The impossible was happening right before their eyes. This finding sent a shockwave through the research team. Blocking the destructive MMP enzymes explained why the cartilage stopped degrading. It was a powerful shield. But a shield doesn't rebuild the fortress walls. What could possibly explain this apparent regeneration? The answer revealed a second, even more profound secret hidden within the pomegranate's husk. They discovered that the same punicalagin compounds were performing a stunning dual role. They weren't just the body's security guards. They were also its construction foremen. You see, deep inside our cartilage are specialized cells called chondrocytes. Their one and only job is to build and maintain the rubbery, shock-absorbing matrix that makes up our joints. But as we age, and as chronic inflammation persists, these cells become sluggish. They enter a state of semi-retirement, producing less and less of the vital materials that keep our joints cushioned and smooth. The pomegranate extract, however, acted like a potent wake-up call. Subsequent molecular analysis showed the compounds were activating a specific signaling pathway within these sleepy cells, essentially flipping a genetic switch from dormant back to active. Suddenly, these reawakened cells began to do what they were designed to do. They started synthesizing fresh type 2 collagen, the specific protein that gives cartilage its tensile strength. They started pumping out new proteoglycans, the crucial molecules that trap water and give our joints their incredible shock-absorbing sponginess. The researchers weren't just witnessing the preservation of cartilage. They were witnessing the first glimmers of active, natural repair, spurred by a plant-based compound. But this discovery also opened a Pandora's box of new questions. If a single plant extract could do this, what else had we been missing? It turns out, they were only looking at one piece of a much larger puzzle. The pomegranate was the shield and the construction crew, but it was missing a critical component: the architect. Thousands of miles away, another ancient culture was using a completely different botanical to manage joint discomfort, a plant with a brilliant golden root. And modern science was about to discover that when the power of the pomegranate was combined with this second, seemingly unrelated plant, the results weren't just additive. They were exponential. This golden root, known to us as turmeric, holds a compound called curcumin. Modern medicine has been obsessed with its anti-inflammatory properties for decades. But our ancestors knew something we had forgotten. They knew that in its raw, potent form, curcumin had a dark side, a paradox that made it almost unusable. So what was this secret? What was the fatal flaw hidden inside nature's most powerful anti-inflammatory? It's that, in its raw state, curcumin is a biological sledgehammer. It attacks inflammation so fiercely, it can inadvertently shut down the body's own critical repair signals. A controlled amount of inflammation is the body's 911 call, signaling repair crews where to go. Raw curcumin cuts the phone lines, so while it might offer temporary relief, it could be preventing long-term structural repair. You're silencing the fire alarm, but the rebuilding has stopped. Was this a dead end? Had nature given us a cure that was also a curse? This is where the story takes its most incredible turn. Scientists turned back to the ancient texts, not for myth, but for chemistry. They discovered that ancient healers never used turmeric alone. They always paired it with a sacred resin, a substance once valued more than gold, harvested from the gnarled bark of a specific desert tree. We know it as frankincense. The ancient texts revealed that this resin, from the boswellia tree, was the missing architect. Its compounds didn't act like a sledgehammer. They were more like a master conductor, intelligently modulating the body's inflammatory response instead of just obliterating it. This botanical architect works on a completely different set of inflammatory pathways. It expertly quiets the chronic, destructive noise while allowing the essential, healing signals to sing through, loud and clear. It reopens the phone lines that raw curcumin had cut, ensuring the repair crews not only get the call, but are guided with pinpoint precision to the exact site of the damage. It turns the sledgehammer into a laser-guided scalpel. When the researchers combined the pomegranate shield and construction crew with the architect of boswellia and the now-focused power of turmeric, the effect was unlike anything they had ever recorded. The line on the graph didn't just creep up, it soared. They had unlocked a synergistic code where the whole was infinitely greater than the sum of its parts. They were witnessing holistic, guided regeneration. The impossible wasn't just happening. It had become the new reality. This wasn't a drug. It wasn't a synthetic invention. It was a blueprint for healing. A code written into nature that had been waiting for millennia for us to rediscover it. A testament to the idea that the answers we seek are often not found in isolating a single compound, but in understanding the profound wisdom of combination. The future of health isn't about finding one magic bullet. It's about relearning nature's language of synergy. It's about seeing the body not as a machine to be fixed, but as a garden to be cultivated, using the ancient, powerful tools that have been provided all along. The journey back to health is a journey of rediscovery. This is just one of the incredible stories we're uncovering. The world is full of these hidden connections, waiting to change everything we think we know about our bodies. If you believe there's a better way to health and want to be part of this journey of discovery, make sure you subscribe to Better_Health. The most important story is the one we write next.